Welcome to Exponential Functions, Part 1. Now, let's start by just defining what an exponential function is. So it's some kind of a function, and here's the key thing. In the function, we might have some kind of a number, I'll just call it a, but the x, the variable part, is in the exponent. And when you have the variable in the exponent, then we say, oh, that's an exponential function. So that's what we're talking about, functions like this. And there's two main types of exponential functions that we work with in math. And one of them is if we have a choice for the base a that's a number greater than 1. So I'm going to do an example here where I've chosen to keep it real nice and simple. How about 2? So 2 is an example of an a or base that's greater than 1. So let's have a look at the characteristics of this graph. We really want to get to know these graphs pretty well, and where we start is with a table of values. Okay, so I'm just going to set up my table here. And all right, so let's plug in some choices for x. I'm thinking we'll throw in a negative number, and maybe 0, and maybe positive numbers. That should be enough to sort of see what the graph looks like. So if I plug in negative 1, I'm going to have 2 to the negative 1, which is the same as 1 over 2 to the positive 1, or 1/2. Okay, so we got that point. Let's plot that point. Negative 1 goes up to 1/2. Then when I plug in 0, that's 2 to the 0. Well, that's going to be 1. So I have the point 0, 1. If I plug in a 1, that's going to be 2 to the 1, which is 2. So 1 corresponds to 2. And finally, if I plug in a 2, I'm going to have 2 squared, which is 4. So right on the outer edge of my little grid here. So there we have it. Now what do we have going on here? Okay, well, let me explain. This has a curvature to it, so I'm going to try and draw this carefully. Okay, so it kind of almost has like a parabolic almost shape. Kind of curves up like that. And what happens on the left here is that you end up with a horizontal asymptote. And I'm going to explain why in just a second. Okay, it's going to do that. Now, how do I know I have a horizontal asymptote? Well, let's say I wanted to look at some point, like say, I don't know, let's go to negative 10 on the left. What is the y value of that? Well, that would be 2 to the negative 10, which would be 1 over 2 to the positive 10. Now, 2 to the 10 is a huge number, but here's the key thing. It's going to be very, very small, yes, but it's still positive. Okay, so if I went to negative 10, I'm still above the x-axis. I'm getting a positive y value. So it means I'm never going to cross into the negative zone. So we have here, just to list some of the characteristics, a horizontal asymptote, and that asymptote is the x-axis, or y equals 0. Other key features, we have a y-intercept at 0, 1. And the range of this particular graph is y values are always greater than 0. Okay? They're always above your x-axis. X-intercepts, there are none. And there's no kind of maximum, because on the right here it just keeps roaring up forever. So that's the basic characteristics. Now keep in mind that was assuming a, the base, is greater than 1. What if we looked at a base that's not greater than 1? Well, the other family of bases that we use in Math 12, and so clear the screen here, the other family of bases falls between 0 and 1. It's still a positive number, but it is a fraction. So I've chosen a nice one here, I think, 1/2 to the x. Okay, and we're going to do the same thing that we did, which is let's make a table of values. Set up my table here. Table of values, and we're going to have a plot in some points here. Let's throw in -1 again, maybe 0, 1, and 2. And let's figure out what the y values are. Oh, I guess we need a grid. Aha, there it is. So if we plugged in -1, just to show you where this is coming from, this is -1, or sorry, this is 1/2 to the -1. And the easiest way to process negative exponents, if you have a base that's a fraction, is to just flip the fraction, right? So this is going to be 2 over 1, which is just 2, to the +1. Well, that is just 2. So we have the point, -1 up 2. And if we plugged in 0, anytime you have something here to the 0, it's just going to be 1. So there's 0, 1 again. And then if I plugged in 1, I'm going to have 1/2 to the 1, which is 1/2. So 1 goes up to 1/2. And if I plugged in 2, then I'm going to have 1/2, and that is squared. So that is 1/4. So we're going to go up just 1/4. So something like that. So what we have here, it's really going to be very, very similar to the previous graph, especially if I can draw it with a steady hand here. All right, there we go. It's good enough. Sort of got that curved part there, and then this side here goes roaring down, and yes, we have yet another horizontal asymptote. So the horizontal asymptote, again, is the x-axis, or y equals 0. Again, the y-intercept is at 0, 1. The range is going to be y's that are greater than 0. All we've really done is, the previous graph kind of went like this, right? It did this. So all we've actually kind of done here is flipped it. So, just to be very clear, whenever the base is greater than 1, you're going to have a graph like this guy here. Okay, this is its basic shape. All these graphs have this little y-intercept in common, no matter what the base is. And then if you have a fractional base, you can see it kind of flips it across the y-axis. Okay. Now, if this number, the base, becomes a bigger and bigger number, like say this was 10 to the x, what you'd have is this basic shape, but it'd be a little bit steeper. It would grow a little bit faster on the right side here. Similarly, if I had something like, say, 1/5 to the x, I have the basic shape of this. All I'm doing is it's a little bit steeper. It's got a slightly different shape to it. But in essence, that is our basic exponential functions. This one is referred to as increasing. And you can see why. As you move from left to right, the graph goes up. And surprise, surprise, this one is referred to as decreasing because it's heading on down. But notice they both never go negative. Anyway, I think that's probably good enough. I think we'll stop there, and we'll pick it up with more on this exciting stuff later on.